Okay, let us start the remaining part on lexicon analysis. Actually, we started the lexicon analysis part in the last class, but due to the disturbance in the internet, we could not complete the final segment. Um, so, what we were looking at that in the lexicon analyzer, inside the lexicon analyzer, there is a finite state machine. And the finite state machine, already I said it is a collection of state. This is a state 4, 5, 6, these all are states. And some tokens or terminals by which it moves from one state to another state. So, and also finite state machine contains one initial state and multiple final state it may have, or single final state. So finite state machine is a collection of states, transition moves, initial state and final state. Now our discussion was that when some codes are fed through the compiler, then the first phase you know that it generates the token. So how the tokens are being generated, that is our main focus, and we will be discussing on that. Already we have discussed the architecture. Already I have shown, where you have seen that for a language, already we have taken a to the power n bc. For that we designed in state machine. This is a, this is b, and let here we are moving here with c. This is another state. Now this is a to the power n bc, and this is a final state. Our discussion was that for this language, if I take a stream bc, it is being accepted because b is here, c is here. No a moves are required. But if I take a string ab, whether that string can be accepted by this language or finite state machine? Not, because a can be here. One move I can take. By moving over b, here I am being trapped. So I cannot move. That means BC, this string belongs to the language L, whereas AB does not belongs to language L. Because if the AB wants to become a language if AB wants to become a language L, actually that means AB12 becomes the part of language L, that is more generic. Then that AB needs to be accepted by this finite state machine. But anyhow, it was not accepted. We trapped in this state. So that is a problem. We are taking some examples by which you will be able to understand. Already we discussed this is a DB keyword part. When some tokens or some strings are coming, then first it is being checked with this database keyword segment. Then these are the states, and if something is being accepted in this final state, that will be taken as identifier. If something is being accepted here, then also it will be taken as identifier. Like if it is accepted in this stage number 6, then it is categorized as real number, or stage number 8, then real number, stage number 7, it is an integer. So different categorizations we have given, correct? Let us see some examples, then it will be more clear to you that what happens here. I am writing integer a semicolon. Now what happens in the first time? So this integer, we know this is a token, this is a second token, this is a third token. We are telling these are tokens, but the specification of token or the declaration of the token should be done by the finite state machine. Now first what happens, this in whatever the token is there, it passes through this initial state. Before entering, it checks with the DB keyword whether the keyword with the same token name exists or not. It finds yes, int is existing. That means existing keyword, so it is taken as a system keyword. So this is the first token. So the second is A. A comes here. Now where A can be accepted? Yes, A can move from state number 1 to state number 4 over the value A. You can check. It can be any value between A to H or J to Z. So only I requires A. Over A, it is moving to this final state number 4, where it is a final state. So that means A can be a valid token. And what is the category of the token? You see the acceptance state. It is an identifier. So A is an identifier. Correct? So A is being accepted. This is a second token. Now semicolon. When it coming in the finite state machine, it is being accepted by this path. 1 to this path. Actually this path. And here there will be a final state where it will be accepted. Though I have not designed the entire diagram because it can contain, as I said, thousands and millions of states. Only few states I have shown here to make you understand how this token generation part is being done by the finite state machine. So semicolon is being accepted. So it is a third token. Correct? So this is a valid syntax I had taken. Now if I had taken this syntax integer a1 semicolon, a is a valid identifier or variable we know. For integer a1, in the same way this is the first token, it will be accepted by the database keyword. A1 means A can be, I can move from 1 to 4 by A, and 1 means I can iterate over 0 to 9. That means any character I can take from A to Z, or any number I can take between 0 to 9 over here. Self loop is there. So I need A, this is the path A, and 1 numeric value. So this is 1. A1 is accepted because again I am in the final state. So this is the second token, and semicolon again from here to here, semicolon is being accepted. Now if I change the this declaration bit in a different way, if I take integer 1a, correct? So for this part everything was perfect. For this part everything was perfect, and 3 tokens are separated by the finite state machine. But we know that if I consider the third scenario, integer 1a, we know that integer 1a, these are both are in a single cluster 1a. We know that a variable declaration cannot be, I cannot start with a number. It should start with a character. So 1a is not a valid token, but we know that. So compiler need to understand that whether it is a valid or not. Only then error can be displayed in your compilation time. Correct? Because again I'm telling that your finite state machine should be equipped with such intelligence that once detecting this entire part, it should able to find it out 1e is not a valid syntax. How it is being done? So let for the int, again the same way it is being checked in the db keyword section. It is being taken as a database keyword. Now the second part 1a. 1 means here I can move from 1 to 7. This is 1, and I need only a. So I cannot move from here to here. This is a point. So here the self iteration that it has, it is 0 to 9. I cannot accept a over here. That means now I am being trapped. Some segment of this token is being accepted, but rest part is not accepted. Only 1 is being accepted, a is not. If that is the scenario, then I cannot tell that 1a is a valid token. Immediately an error will be reported by the finite state machine to the compiler that 1a is not a valid syntax, which I can take either in form of integer or in form of real. It should be rejected. That's why you have seen some compilation error if you make a wrong declaration in that variable segment. But semicolon is a no problem is there. Semicolon is being detected. Let's change our scenario a little bit. If I had written this sentence, integer a semicolon. You know, in the fourth declaration that I have made in blue color, that here integer it is taken as a single token, you know, because it is checked by the database keyword segment. Again, this integer, the second word, again is taken as a second number 1, number 2 token. A, it is a third token, semicolon is a fourth token. Because every time int and int is fed through the system, this finite state machine cannot check that whether this int is applied twice or thrice. It checks whether this int exists or not in the db keyword section. But we know that this declaration int a semicolon that we are making, it is not a valid declaration. There, because there is a syntactical error. Why syntactical error? Because if I am declaring a variable, before that there should be a data type. It is an integer. But before integer, another data type is there. So it is not following the syntax that it should follow. That means this, the fourth portion, this is the first. It was perfect, no problem was there. It was also a perfect one. Here there was a lexical error, correct? So I am writing lexical error here. I am writing. It had a lexical error. But here in int A, there is no lexical error. But the error is actually syntactical error. Because finite state machine that I have drawn here, it is easily accepting this int A semicolon. It cannot categorize how many times this int is being repeated. Okay. I'm taking a different scenario, then you will be able to understand it more clearly. Had I taken this format, I am writing integer x equal to 2, character, let it is ch, then I am assigning ch equal to x. This is a complete code segment. Now here everything is perfect. In the declaration part, in the first line it is perfect, second line also perfect, in third line also perfect. What I have not done here, I have not done the type casting part here, because x is an integer. I am assigning an integer to a character, so here the type casting operation need to be performed. But if you try to compile this code in C compiler, then only an warning will be displayed in the screen. And that message actually shows that incompatible assignment you have made. But still you can execute the code. But the warning that it is showing, it is also comes under the error category. Because if you are making some mistakes or forceful assignment, only then some warning are being displayed. So compiler is being said that okay, you can deal with that scenario, but still you should report to the coder that they have made some forceful assignment. So here int x equal to 2, character equal to ch equal to x. So lexical, no errors are there because everything will be accepted by the finite state machine. Int will be accepted, x, an equal sign, 2, then semicolon, it will be accepted. Character ch semicolon will be accepted as 3 tokens. Ch equal to x semicolon will be accepted as distinguished 4 tokens. Now, syntactically, is there any problem? No syntax problem. For x, there is a perfect assignment. 2 is being assigned to x. X has a declaration or data type integer. Character has a declaration. Ch has a declaration character type. The value of x is being assigned to ch. So syntactically it is perfect. Then what type of error is there? In this code, no lexical error, no syntactical error, only error is the semantical error. Semantical means the sensitivity error. Because the cast, I am changing the type. So x has a cast of integer. I am changing the cast of x to a character. So how I can change someone cast without informing someone? If I am changing my cast, I am moving from one caste to another caste, I need to inform the government as well that I am changing my caste, because in my other database that will be reflected. So same time, in this portion, either he has to make the typecasting part or should inform someone that I have changed my caste. So here the assignment is being there. This is a sensitivity part, correct? That every time I'm changing the x to ch, I am operating over some sensitivity issue, correct? So some sensors are there, like you can assume. So this is an error belongs to the category of semantical errors. And if I scroll up, then if you can remember in the last class I said Just a minute. That I said that lexical analyzer is connected with regular grammar, finite state machine. Context free grammar is connected with this syntax analyzer, context free grammar, CF. And semantics analyzer was connected with the context sensitive, I said last time. So why this sensitivity term comes in semantics analyzer? Due to that reason, because whatever I am writing in my code, if is there any sensitivity issue is there, then those are being tracked by the semantic analyzer. Correct? That is the reason this grammar is named as context sensitive grammar. Okay. Now I'm taking one more example here. For example, had I written this sentence, printf red double okay, and instead of semicolon, if I put colon, then what type of error is it? So printf, this is a valid part. This is token number 1. This is token number 2. You know, within the double quote, whatever I write, that is categorized as a 1 token, 3rd token. This is a 4th token, and this is a 5th token. Because printf is a keyword, will be accepted by the DB keyword section. This open bracket will be accepted by some of the paths that will be here. This colon part also, that will be accepted by the some of the roots that will be originating from here also. This is the colon path. So here lexically you cannot tell if there any problem is there or not. But syntactically there is a problem, because we expect that at the end of an instruction there should be a semicolon, not a colon. So the error that I am finding out here, that is a syntactical error. I hope now you will be able to tell what type of error is it. If any sort of error is being given to you, you should be able to find it out whether it is a lexical, syntactical, or semantical error. Let another one more example. If I take, had I taken this format, let float x equal to 2.5. Correct? Float x equal to 2.5. So whether it is a valid syntax or not. Float, this is a first token. And why I have taken this example, basically, you know that 2.5 it is a single digit. But whether compiler takes 2 as a token, point as a token, or 5 as a token or not, that is the reason, that's why I have taken this example. So float, it is being checked by the DB keyword section. It is being taken as a single token. X is a valid identifier. It is taken by this path. Equal to sign, this is the path for equal to sign, and this is a final state. So it is being accepted. Now, what about 2.5 or 2 different point, different 5 is different. So first it takes this part, 2.5 first it is taking. So 2 can be accepted from here. From 0 to 9, 2 is here, you check. From 0 to 9, I can take 2. Then the point is coming over here. This is a point. And 5 means here 0 to 9 iteration is there. So 5 can be accepted. So 2.5 is accepted up to here. Correct? So that means 2.5 will be taken as a single token. Then finally the semicolon comes. That also will be accepted as a token. Correct? So once 2.5 is accepted, it is category. So 2 point, here it is 5, and it will be categorized as a real number because it comes under the real segment. Right? So the main purpose of finite state machine, if I summarize, then is to generate the tokens, but at the same time to check whether any erroneous parts are there in the declaration segment of the token generation segment of the finite state machine or not. If the finite state machine cannot take, then error will be reported. That error will be lexical error. Okay. For example, one more example, if I look at here, if I had written instead of if I had written 5, a equal to 2, then this part had I written, then what happens? So now, okay, before moving to this segment, let me give one more example, then it will be much more convenient for you to understand. Let me erase this section. Okay. Okay, let me clear this part first. Now, I have taken this declaration integer 1a semicolon. What I tried to write, actually, my intention was to write integer a1, but I had written integer 1, then a, and then semicolon. And again, I'm writing in a clear way. This is a bit inclined. Integer 1, then a, then semicolon. Now, whether this error, now there is an error is there because this is a variable, it should have a data type. But what is the data type? Int1 cannot be a data type because it is not a keyword. Now, once this entire string is fed through the system, int1 passes through here. First is check with the DB whether int1 is a valid keyword or not. It finds no, it is not a valid keyword. It processed through the different stages. It tried to accept this int1 segment, whether int1 is a variable or not. I don't know. Actually, I means the finite state machine does not know whether int1 is a keyword or int1 is identifier, because int1 is already being rejected by DB keyword. It already have said there is no existence of the set token. Now int1 means let I am moving over I over here. That means first I. N means I can move over A to E, G to Z, N. Then T means again A to Z, int. Then 1, the last character 1, again it can be accepted by 0 to 9 movement. So int 1 is accepted and it is accepted as an identifier. Okay, so that means it is a valid token that is being accepted by the lexical analyzer and it is categorized as a valid token and it puts int 1 in the symbol table by considering it is an identifier. For A and semicolon, there is no problem. What I wanted to show here is that if I make any error in the keyword section, then those are categorized as an identifier by the lexical analyzer. So any errors in keywords is not able, so the finite state machine is not capable to find it out that whether the errors are there in the keyword or not. So lexical analyzer is not capable to find it out this into an error, right? So now if I am coming to this question, then had I written instead of if, had I written phi, so phi it takes as an identifier by the compiler, that means the finite state machine, then a double equal to 2, all are taken as tokens. And in lexical analysis phase, no errors are being reported over here because everything is perfect now. But once it enters into the syntax analysis phase, it finds that we are checking that whether a is equal with 2 or not. Before that, there should be a keyword in form of if or in form of else if. But here we have written only phi, so there is a problem. So there is a problem in the syntax or the declaration part. So this comes under the syntactical error. Or had I written instead of for, had I written fro. This is also a syntactical part because lexical considered this fro as an identifier. But whether the syntax, this is initialization, checking part, incrementation by decrementation, this is perfect. But this structure only belongs to the for loop. So whether for is there or not, oh no for is there, only fro is there. That means there is a problem. So the syntax analyzer find out the error. Correct. So what is the statistical analysis is being seen that if I consider 100% of errors that we are making in a code, then 80% of errors are being checked in the syntactical phase, in syntax analysis phase, more precisely if you want to say. Only 20% errors are there, maybe semantical error or maybe lexical error. Correct. So syntax analysis has a lots of works to do before it process the entire structure to the semantical analyzer. Correct. Now, if I summarize what we have learned in this segment, that our lexical analysis is over. That lexical analysis contains a finite state machine. It checks which token to be accepted, which token are not to be accepted. If it is being accepted, that means the string is being accepted, it is declared as a token. If not accepted, then cannot be called as a token. In the next segment is, we have seen different errors, though I have erased some of the portions, and which type of error is it, so that categorization we have seen. Correct. And now if you can recall the symbol table part, in my first video I said that symbol table had numerous columns. Correct. Now you will be able to understand some of the segment that I said that time, that once a variable be declared, let it is a temp or x or y, immediately that we insert that part into the symbol table, because symbol table is being connected with all the phases. The first video I said. Now also I said at the time that a symbol table may contain thousands of columns considering different properties like type, scope, size and storage allocation. Now you tell me that this type property, can I fill this type property in lexical part? No, that is not at all possible, because lexical only find out lexical error part, whether it is belongs to the character type or integer type or float type. That is a sensitivity issue. So this type part data is only filled by the semantical analyzer. That's why, so one question may comes into your mind that then this portion, this cell remain vacant. Yes, initially these cells remain vacant. Once the token is being generated and act and set as a valid token in the lexical phase, it is being inserted in the symbol table. This cell is being filled in the semantical phase. For example, scope, whether the variable has a local scope or global scope. Again, that part, sensitivity part, is being filled by the semantical analyzer. For example, size, whether it is a long int or short int. So this part, or whether the storage allocation, the memory address, in which memory it is being stored. So neither of the three phases, lexical, syntactical or semantic, should have that information. Once the machine level code is being generated, then only the memory address I can fetch. Correct. So this information can be filled in the code generation part. Like that, some more columns may be there. Only some of the portions I have shown you. So now, now hope you will be able to understand what is the reason that all the stages are being connected with the symbol table, because x temp is a variable is being declared by the lexical analyzer. Then for this temp, semantics analyzer filled up what is the property. It is an integer temp. So first, semantic analyzer checks whether really temp exists or not. So data retrieval is being done. Then first is verification is done, temp. Then data retrieval is done, and then the updation is being made. Yes, the type is integer. Correct. So all the phases, that is the reason, is connected with the symbol table. And we have also seen the different errors that can be tracked by the finite state machine, and some categorization also we have seen. In the next class, we will be moving to the generation of the parser. Okay, and some fundamentals are also there. You can go through it. Let me check. Okay, this ambiguous part we will be covering in the syntax analysis phase. Okay,